Question 34. Given the following sinusoidal equation, p is a function of t equals 3,000 sine of pi over 10 outside of t minus 2010 plus 10,000. So I think this is probably describing some type of population over time with the initial value maybe at 2010, but doesn't really matter because we're asked to determine the maximum value of p of t and a value of t at which the maximum occurs. So we want to go through each of these constants. So 3,000 is the amplitude. This 10,000 here is your center. So we're centered on 10,000 and we go between 13,000 at the maximum and 7,000 at the minimum. 2010 is our shift. So 2010 units to the right. And this value in here, pi over 10, is used to get us our period. So our period equals 2 pi divided by b, which in this case is 2 pi divided by pi over 10, which is the same as 2 pi times 10 over pi. So our period is 20, and that's probably in years. So I think the best way to do this question is to sketch it or do a really rough sketch. Before we do a rough sketch, we again want to review our good old sine graph. So if we just do a sine graph sketch, the highest it goes is 1, the lowest it goes is -1. It goes from 0 to 2 pi. It has a period of 2 pi because it's in the circle. So sine starts at the center. It reaches its maximum at pi over 2. Then it goes back to the center at pi. And it go down to a minimum at 3 pi over 2 and back to the center at 2 pi. So that is one complete period. So here it goes. So something like that. So the main descriptor for sine, what I think is important, is it's increasing through the center. Increasing through center. So how can I apply that to this particular function that we have to graph? Well, the first thing I want to notice is it's centered on 10,000 and it goes up 3 and down 3. So that should give me a good idea of labeling my that should really help me with labeling my y-axis. So I'm centered on 10,000. So this is not going to be very accurate, as most of my graphs are. So it goes up to 13,000. And already I've answered the first question, the maximum value. It goes down to 7,000. And I should put, oops, that's 70,000. I should put a little squiggle here just to show the axis is compressed. It's not to scale. So the other thing is this graph is being shifted to the right. So if we want to think about our parent function here being shifted over to the right, well, it's shifted over 10,000 units. So again, that's a long ways. Sorry, it's shifted over 2,010 units if I read what I wrote. So it's going to start at 2010. So at 2010, if this was at the center, this one's at the center. So our new center's 10,000. And it goes on for a period of 20. So this is going to go to 2030. So it completes one full cycle. It's important to note that a full cycle is not going up and coming back down. In between, as you can see up here, in between your full cycle, you do have a 0. So what's in the middle of 10 and 30? The middle of 10 and 30 is 20. So I want to make sure that right here is 2020. So that's another 0 for my function. So now where would the maximum? Sine is increasing through the center. So my maximum is going to be in the middle of 2010 and 2020. So my maximum is going to be up right here at 13,000. Let's make that look like a 3. But it's going to be right in the middle here, which is 2015. And then it doesn't ask me about my minimum, but my minimum is going to occur at 2025. So let me draw a nice smooth curve here, going up, coming back down, coming back up. Okay, so as long as you could pick out my numbers, I think I could answer this question. So what is the maximum value? The max value is 13,000. And it occurs when we're talking about a variable of time. Time equals 2015. So I guess in reflection of this question, it's very helpful to do the graph, but one thing I want to note, and for future reference, is if you're talking about a sine graph, right, the maximum occurs at a quarter of the period over, right? So if my period is 20, is what I said, a quarter of that period is 5. So where does the maximum occur? It would occur 5 away from the start of 2010. And in hindsight, that may be a better way of doing this question, but I think the graph really helps us visualize what's going on.